Good morning, children. Let us continue the velocity time graph. In the last session, we discussed about various types of velocity time graph for uniform acceleration, non-uniform acceleration, zero acceleration, retardation. Various graphs were discussed. Now, in this session, we'll discuss how to calculate acceleration from velocity time graph, and from the graph we can calculate the displacement or the total distance covered can also be calculated. Suppose we take an object is in uniform acceleration. In that, the object may start with zero velocity or already it may have some velocity. Let us take the second case. The object, suppose in this is velocity time graph. Velocity time graph. In the beginning itself, the object is having some velocity. So it is having this velocity. At time 0, it has some initial velocity. The initial velocity is not 0. From there, the object is in uniform accelerated motion. The uniform accelerated motion means it gives the straight line like this. So it travels up to this much of time. Up to this time, it travels and its velocity become this value. Finally, its velocity become this. So here at this point, we take its velocity is initial velocity, that is u. At this point, it is having the final velocity v. At the beginning, its time is taken as 0. Here we take the time as t. Take anything. Now from this velocity time graph, if we find the slope, in distance time graph also we find how to find the slope. Here also we are going to find the slope of this graph. For that we can take 2 points on the graph anywhere. Let us take the 2 points at the starting and at the end. Then from the starting, draw a parallel line to the time axis that meets the line from another point and it forms a triangle. Let us label it. It is A, B, C, this is O, this is D. Now if we take the slope of this line, slope of this line means, this graph means, it is the angle. It is making an angle with the time axis because it is parallel to time axis. That's why I said this is the time axis. With the time axis, it makes some angle. And that angle, there is a trigonometric ratio that we will discuss later on. That angle made by that graph with the time axis, that is the slope. If we find the slope of this AB, slope of this AB, this line, the slope that is equal to perpendicular to the base, perpendicular, that side opposite to angle, base adjacent one. Here the slope of AB is equal to BC upon, it is AC. BC, at point B the velocity is V, at point C the velocity is U. So the BC is equal to V minus U, that is change in velocity, upon AC, that is equal to the time from 0 to t. So that is t minus 0, that is t. You know that change in velocity per unit time, that is the acceleration. That is acceleration. So by finding the slope of the graph, velocity time graph, we get the acceleration. That means conclusion is the slope of VT graph always gives acceleration. Whenever you find the slope of velocity time graph, it gives the acceleration. Since the slope is same at every point, if I take the point here, here also the same angle is formed. If I take the point here, the angle is same. It means the slope is same throughout the whole line. So its acceleration is same. So that is uniform acceleration. So we got one thing. The slope of dt graph gives speed. The slope of vt graph gives acceleration. Then in this case, if we draw this graph, this is velocity time graph, we are getting this one. In the same velocity time graph, if we obtain this type of graph, this is also velocity time graph. It represents the object is in uniform acceleration. It represents it is in retardation. That is uniform retardation. From the graph we can say, here this is the angle made by the graph with the time axis, and that angle made by the graph with the positive time axis on the positive side. So the angle is acute. If this angle is acute at this point, then the slope is positive. If the slope is positive, acceleration is also positive. Here you see the graph is meeting at point this one on the x-axis, on the time axis. At this point, if we measure the angle made by this graph with the time axis, positive x-axis, it is obtuse. If we get the positive, that is obtuse angle made by this graph, then the slope is negative. This is positive slope and this is negative slope. Negative slope. For positive slope, the acceleration is positive. Negative slope, acceleration is negative. That is retardation. So these are the two things should be kept in mind. Then one more thing can also be calculated. From the slope we got the acceleration. One more thing can also be calculated from this velocity time graph. That is, since this graph represents the velocity time graph, that is change in velocity taken place in the time interval. If there is velocity, then the object continuously moving. As it moves from one point to another point, definitely it covers some distance, or definitely there is some displacement. That displacement can also be calculated from this VT graph. How we are going to find out the displacement? Displacement, or we can say distance in a given direction. Since here we are discussing that the object is traveling in the same direction, you can use the word distance or displacement. Now you see, from the initial point to final point, the object has covered some displacement, some distance in a given direction. To find that, join that 2 points with the y-axis and x-axis. Then we get a closed figure. Now we are having the closed figure, that is OABD. This is the closed figure formed by this graph by joining with x-axis and y-axis. Now for this figure, we are going to find the area, and this figure definitely you can observe it, that is trapezium. If we find the area of trapezium, area of OABD, you know the formula for area of trapezium, that is half into height into sum of parallel sides. This is equal to half into height Instead of saying height, you can say it is the distance between two parallel lines. Trapezium like this. This is trapezium. Height means the distance between two parallel lines. The distance between two parallel lines, now you must find out the parallel lines. This is one line and this is another one. These two are parallel. The distance between them is this one. So this is equal to time interval. So it is t. It is t. Then into sum of parallel sides. This is one parallel side, another parallel side. This parallel side, that is equal to OA. OA, that represents the initial velocity and this represents final velocity. So you can say it is sum of parallel sides. This is u plus v. You can write. Here we are getting half into time into sum of that velocities. Here we took the initial velocity is something. If initial velocity is 0, the graph will be drawn like this. In that case, if u equal to 0, we get half into t into v. V. That is velocity into time. Velocity into time. Velocity upon time, that is v minus u upon t, that is equal to what? Acceleration. Initially if it is 0, then we get v upon t equal to acceleration. That is velocity upon time is acceleration, but velocity into time, that is the displacement. That is displacement. So by finding the area of this figure, we are getting displacement. Displacement covered by the object from one interval to one time to another time. So by finding the area of the VT graph, we got the two conclusions. The first conclusion was slope of VT graph, then area of VT graph, slope of VT graph gives acceleration and area of VT graph gives displacement. Since the object is traveling in the same direction, we can write distance also. So the distance traveled or displacement can be obtained by finding area of VT graph, slope of VT graph, acceleration. So these are the two important conclusions we obtained from velocity time graph. And the next thing related to this graph, we will have the set of equations of motion that we will obtain in the next lesson.